Hello, welcome to part 3 of our Climate Change Emergency Masterclass. We're going to discuss what actually does drive weather and climate. And we just begin with when I asked this very question to the CO2 believers, namely a professor at the University of East Anglia, and this was done in a Royal Society meeting where they were discussing the latest United Nations report. So I stood up and I said to her, what, in your estimation, is the evidence of, on Earth, of the warming which you say is driven by CO2? What is the evidence of the process? And she said, 1, Venus, which isn't on Earth, but she said Venus, which has a lot of CO2 on it, and it's hot. I just said, look, that's not Earth, and Venus is nearer the sun. And then she said, the second point is that my assertion that extra CO2 can cause cooling of the surface when it causes more transpiration of plants, she said what I said about that was an overestimate. Well, I hadn't given an estimate anyway, I just said it was something to look at. And then the third thing she said is, it can't be anything else. Now look, this is ridiculous. But notice they didn't produce any actual evidence because there is none. They have assertions and a belief that CO2 is somehow bad. Right. Now we're going to look at, as I said, what does actually cause it in reality. Standard meteorology, you see, says that weather drives weather. Well, okay, so far as Met Office short range, a day ahead or even 2 days ahead, detailed forecasts, they're brilliant. Most of the time, they're brilliant. They, can produce a lot of detail using supercomputers based on what's just happened, projected forward in time using standard physics equations, and it works. However, if they go 4 days, 5 days, 10 days, 20 days, they get into a lot of trouble and it doesn't work. You can't project forwards like that. And the reason is, of course, there's other things happening which aren't involved in their equations. There's inputs from the sun, there's lunar effects, there's many things. There could be other things that none of us know about. But they don't involve those. And the actual observations show, as it says on this picture, that there are signals in real data. There's a 22-year signal in real world temperatures, which is from the 22-year magnetic cycle of the sun, which is twice the 11-year cycle. Okay. There's a 60-year cycle. There's 155 days, which is also the period between extrasolar flares. There's 27 days concerning with the spin of the sun relative to the Earth, and so forth. And there is only a little bit of CO2. But that apart, there's no signals that are going to come out of a CO2 story. But they do come out naturally from a solar-based story. So here we have that graph again, Tim Ball and Hubert Lamb's graph. Hubert Lamb, by the way, was a former professor at the University of East Anglia Climate Research Unit, a brilliant man. And I did have correspondence with him because he was ousted from the department he'd set up, or let's say his importance was diminished as almost zero, when they started imposing the CO2 story. He was really upset about it, and he wrote to me, I had some correspondence. He said, Piers, keep on with your work about solar, because he believed it was true. That was the basis of weather, he said. And he was very annoyed, he said in his letters to me, that his work had been taken over. His organisation had been taken over. Anyway, let's go back to this graph. The upper one is, as you see, the medieval optimum, medieval warm period, and then the Spora minimum of solar activity, the little ice age minimum of solar activity. But these are temperatures, but they all correspond to the graph below, which is a representation of solar activity by various measures involving carbon-14. So there's a large, higher level of solar activity underneath the medieval optimum. And underneath the Maunder minimum, for example, labelled little ice age there, that you see the low solar activity. And underneath the Dickens winters or the Napoleonic Wars, etc., you see the Dalton minimum. And, you know, the timings are okay and the graphs might not be completely aligned. But that is the basic message, that smoothed out temperatures follow smoothed out solar activity, as long as you smooth it out over typically 20 years. Okay. Now, what are the mechanisms then for causing changes in weather and climate, especially weather extremes? That is a big question. Now, any meteorologist will say, well, if there's a big change in the weather, the jet stream has changed. True. Question, what moves the jet stream? Our answer is the jet stream changes are driven by solar particle magnetic activity and lunar modulation, which is largely predictable. So we can make long-range predictions using these ideas. The CO2 theory can predict nothing. I'll repeat, nothing. They claim to predict things, but all they're doing is looking at what happened and say, oh, it might be CO2. We say, no, no, no. We've made specific predictions for most serious storms that have hit Britain, America and Europe in the last 10 years. Okay, so the message is low solar activity shifts in the northern hemisphere the jet stream to the south, and it makes it more wavy. And most weather parameters, variations therein, can be explained by our solar weather technique theory, as it was called and now called solar lunar action technique. And there we have more pictures of the jet stream, and we advance our theories as we go along. As we find out errors, we can quite often, but not always, work out what's happened. And there's a picture of the sun there, a model, and there's a little tiny dot with an arrow on it, you can see, which represents the Earth. So, you know, the idea that variations in the sun aren't that important for Earth is just a bit bizarre when you look at that picture. Instead, they're saying that CO2, which is, 4% of 0.04% is the crucial thing. It's not very tenable and it's not borne out by reality. Now we're going to look at the periodicities observed in real weather and real climate, which we'll come to after we've got a bit of understanding of what's happening outside the jet stream. You see, there's a picture of the Earth, that little round thing in the middle there, and the surface of that, basically, which would be just like a piece of cardboard on that globe we have as equivalent, that's where most of the weather happens, up to 10 miles up, and there's a jet stream in that, right? But way outside all of this, going to 2, 3, 4 2 or 3 or 4 Earth radii, we have electric currents going around, connected with the rush of particles from the sun, which are charged particles, the magnetic fields connecting the sun and the Earth, and so forth. So they generate many, many things happening. And these are connected with each other. What happens way up there with electric currents has an effect on what happens with the jet stream and indeed weather developments in general, especially big storms. And the odd cycles of the sun and even cycles of the sun will have a different relationship to the Earth, because essentially the current or current sheet which comes out from the equatorial regions of the sun. In odd cycles it will be largely negative ion flow, i.e. electrons, and in even cycles it will be largely a positive ion flow, like protons, and these are going to react differently with the Earth's magnetic field. There's a different connectivity between the sun and the Earth during the different solar cycles, odd and even. Now we have a little diagram here of periodicities, if you like. This is just a graph. It's called Fourier analysis, but don't worry about it. It's just a diagram, if you like, to say, well, the top one shows that if you look at geomagnetic activity, which is the wobbles in the Earth's magnetic field caused by the solar wind hitting it, that has a periodicity of intensity in its wobbles of geomagnetic activity. That's got a periodicity of 11 years, which is the same as the sunspot period, the number of sunspots counted on the sun. So that gives you the particles. But it doesn't tell you how they're going to be connected with the Earth, because there's magnetic links which are going to guide them in different directions, because the sun's magnetic field changes direction every 11 years. So there's a 22-year repeat cycle of magnetic direction. Connectivity direction. And interestingly, the lower graph shows the diagram of temperature periodicities, and the biggest one is the 21 or 22 years. It's twice the normal solar sunspot cycle, and that is very important because it means that it's the sun magnetic effects which are ruling and the conveyor of activities, inputs from the sun. The connection is direct. It's not indirect via cosmic rays, for example, which are modulated by the amount of magnetic activity. So if cosmic rays were the key connection agency whereby the sun and the Earth were connected, we'd have to have an 11-year cycle in temperatures. This we do not have, or we have a very small one. The key cycle is 22 years. So cosmic rays are important for many things, but not for actually the weather. They can do things to you, that's true, but that is something else. Don't ignore them, but don't get deluded by what people say about them. It's the sun, what does it? Now, there's a really interesting piece of information here. As I said, it's the sun, what does it? The upper graph is temperatures, and the lower one is the upper graph is geomagnetic activity, and the lower one is some important measures of the current flow north of Norway into, or in and out, but into the polar regions. So the way the polar regions melt or not melt is going to depend, importantly, on this current. And if you look at that graph, you can see that in quite a lot of instances where there's peaks in the geomagnetic activity, there's peaks in that current, and troughs in the geomagnetic activity, there's troughs in the current, which is very remarkable because it means that there's a direct link between ocean currents or some aspect of ocean currents and solar activity, in particular the Sun-Earth link, which leaves out the atmosphere. Of course, this isn't something that standard meteorology can cope with, because we're going to have the sea being affected directly by the sun, and then the sea is going to be affecting the air. So obviously, standard meteorology is going to run into trouble. Now, you say, well, how is this? Well, the answer is that, and this, of course, I'm showing you another stack of equations, but it's just to look at. And of course, I could wave everything and anything, and you might think, oh, that's wonderful, it's physics and so forth. Well, right, but just read it and think about it. But the argument is, and if a physicist tells you something, if he can't also tell it in words, then there might be something wrong, right? But here, these equations describe the interaction of the magnetic fields with the sea, because the sea is a conductor. So changing magnetic fields can generate electric currents in the sea, and these of course can counter-generate magnetic fields and so forth. So you will have effects from the solar wind upsetting the Earth's magnetic field, penetrating into the sea. Very important for understanding, although the details are not well understood. But this is a basic idea which works. So now we're going to have a little talk about how are we going to develop into this new little ice age. Because the graphs in the past showed it happened quickly. It happened quickly. Well, there's some questions. We're asking some questions here. Are quasi-equilibrium assumptions valid? That is, the standard metrology assumes, well, everything's pretty well always in equilibrium, and you use that. Now, that's the way to work things out in physics because it simplifies everything. But are these things always valid? Which might mean there'll be times when we can't work things out. That's all right. Next one is, do temperature changes require temperature changes of surfaces? An average surface temperature, say. Does it require changes in heat input, which is interesting? And of course, what changes the jet stream and even the spin of the Earth and so forth? Well, quasi-equilibrium assumptions valid? Well, the answer is probably not, or sometimes they're certainly not, because the ice ages came and went with colossal speed. Compared with the amount of heat energy involved in all those icebergs. So something very rapid was happening. It might be very big sun-Earth changes. We don't know, but things are not as simple as the smooth running of standard meteorology. And then the idea of, what about a surface? Can you change the temperature of a surface by not putting in heat or taking out heat? Well, actually you can, funnily enough, because you have a table, say, spread some snow on half of it, and then spread the snow out. Well, okay, the surface temperature then has gone from something to something colder just because you spread the snow out, right? And you see the way the jet stream operates on the Earth is relevant to that as an example. So the shifts of the jet stream are key to weather and climate. You can study that slide at your leisure, and here we have a bit about what are the agencies of connection. Now, there are many agencies of connection, i.e. modification of weather. There's volcanoes, changing forests, but not CO2. There's solar activity, definitely, and questions about what rules solar activity. There's magnetic linkages, and there are direct effects, electrical effects with the sea. Okay, now the best way to maybe summarise it is to look at this picture. There's nothing fundamentally new in weather, and it's essentially all happened before. And how it is linked up is we have solar activity, which changes. That affects the solar wind. That changes the magnetosphere and the ionosphere of the Earth, which has some effect on volcanoes and earthquakes, which is a technical idea, but let's just leave that aside for the moment. But certainly we can see the magnetosphere change the jet stream, that changes the weather circulation and climate. And that will control, especially through sea temperatures, the amount of CO2 around. CO2 is the gas of life. CO2 is not controlling the weather, and the weather is not controlling the jet stream, and the jet stream is not controlling the magnetosphere, and the magnetosphere is not controlling the sun. So when you drive your car fast around your town, don't worry, it's not going to cause a solar flare. Okay. Right, now what about this coming mini ice age? Well, so this is about the mechanics of it. You see, what we have now is generally low magnetic and particle activity from the sun with occasional bursts of extra activity. This means that we're going to have the jet stream in the northern hemisphere south shifted and wavy. It also means, and this is statistically known, that we get more major earthquakes and volcanism in these periods of low solar activity. Now, the jet stream itself will, when it shifts south, means the area of winter snow increases because the area above the north of the jet stream is larger, i.e. it will be at a lower temperature just because the snow there has got spread out. The average temperature of that region will be lower. And that extra ice will reflect sunlight. The albedo effect is called, but it will reflect sunlight, i.e. keep sunlight away from being absorbed by the ground. And this last year, the extent of winter snow in the northern hemisphere on land was the biggest it has been for 50 years. That then is reflecting more sunlight, which means it's going to be colder, as it's shown in the diagram, and that means next year around is it going to be even more snow. And at the same time, in terms of earthquakes and volcanoes, we have more volcanoes. Some of those will have ash which reach the stratosphere, and already have been some which reach the stratosphere. That blocks out sunlight. So we're now in the feedback system where more and more effects from the sun are going to cause cooling, which is expanding the winter snow area, which is reflecting more sunlight, which is making it colder. So we're going to have an acceleration into the little ice age. Now we're going to have a look at some examples of important successes of the solar lunar action technique. And we are provenly skilled with independent peer-reviewed scientific papers showing that, and no other long-range forecasters have skill. When I say long-range, I mean, weeks and months ahead. Or if they do have skill, they haven't got it peer-reviewed and published. We have. Okay, so this first slide here, it's kind of just to get a quick understanding of what we do. We basically say there's nothing really new in the weather, it's all happened before. Most of it, certainly. So we're saying any world parameter or even local parameter is going to be a product of something to do with solar activity, which is an 11-year cycle, the magnetic linkages with the sun, which is a 22-year cycle, and lunar modulation, which will be these 18.6 or 9.3-year modulations. And there'll be other things as well, stratospheric winds and so forth. But whatever agencies or mechanisms there are, if there's patterns in these drivers, there will be patterns in the weather. So our idea is that the total Sun-Earth magnetic and modulation weather state will give you generally a weather situation. So if you like, the solar weather technique state will give you a weather state, or the solar lunar action technique will give you a weather state. So it could mean that roughly, but it's not going to be clockwork, so be very careful. If you notice 6 times 22 is 132, and 7 times 19, that's roughly the lunar modulation issue, is a similar number, 133. So maybe you could have extreme events, especially 131, 132, 133 years apart, which would come again, or something like that come again. So I put this forward at a dinner in Imperial College, a centenary dinner for Imperial College Student Union. that the floods that were happening, because it was raining in Wimbledon and the Trent Bridge had been flooded and so forth, where they were trying to play cricket, that was recorded in the Trent Bridge. So I said, well, if this idea is true, then we could be going to have floods in 2008, 2009 and so forth. And people said, well, OK, Piers, if you say so. But they were pretty sceptical, I would say. But it doesn't matter. I said, well, let's just have a look. Let's see what happens. And anyway, it did happen. You see, there was a string of very wet summers in 1875, 1876 and 1877, recorded by the measurements marked on the bridge for the River Trent. And lo and behold, there were floods in 2007, 2008 and 2009, which we predicted. Not necessarily the same dates or anything, but, wet summers. And even going as far as 2012 and 1880, the heavens opened in both those years. And here we have the years. The Met Office, you see, had been telling us CO2, there's going to be barbecue summers. They said 2007 barbecue summer. We said it was going to be floods, and there we have their barbecue summer, our floods in Tewkesbury. Well, if you have a barbecue on a boat, I suppose it's possible. Then we had another one, 2008, 2009. Floods, floods, floods. So we were very pleased with that. And, of course, we've developed better forecasts even since then. Now, let's have a look at some of these very interesting ones. It was a big round of stuff in 2010, 2011. Very cold USA winters, we predicted those. Tropical storms, Yasi in Queensland, series of American tornadoes, and Hurricane Irene. A very interesting Hurricane Irene. We had predicted it would start developing in the Bahamas and skirt the edges of the US of A. And we predicted that, I think, about 12 weeks ahead. And we told NOAA about it, the American Met Office sort of set up. And they were very interested. And I said, it's coming. And they saw it there, and I found out, I said, yeah, OK, but it's not going to go into the land like you're saying. It's going to stay away, because we have various reasons for this argument. And that's what happened. But during it, they said, Mr. Corbyn, this is really interesting. Afterwards, we'll talk about it. They were genuinely interested. The guys I talked to were genuinely interested. But I phoned them up afterwards, and it was as if I didn't exist. It was, they didn't want to talk about this stuff because it upset the narrative being imposed upon them by President Obama, because he wanted to bus people all over America to save the planet and give them free cups of tea and so on, But they didn't even want to advance hurricane forecasting. I mean, maybe some of them do now because things are changing politically, but, the ideological imposition of CO2 theory, dogma, is holding back science. Another one here, good one, very big heat wave in Russia, which we predicted, and we also predicted when it was going to end. And corresponding to when it was end, there was this amazing double solar flare, sunspot on the sun, and within 15 minutes of that, there was a major disturbance storm in the ionosphere. So something was travelling, some effect was travelling at half the speed of light. That amazing storm. Later in 2010, we had the very snowy winter, the very cold December. And we said it was going to be the coldest in 100 years. And David Cameron said it was the coldest in 100 years. So if he said it, it must be true. Possibly. Now, during that, I was phoned up by the BBC, and they said, Mr. Corbyn, we heard you predicted this. Will you come along on to our morning show? I said, yeah, sure, I'll do that. But there was a young researcher phoned up, you see, and I said, oh, yeah, but I don't think your boss would be that interested in me. And she said, well, of course we're interested in it. It's important, isn't it? I said, yes, it is important. And they said they'll book a cab. Okay. So I was waiting there with some friends, and nobody phoned up. So I phoned them up. I said, well, what's going on? I've got to, find out when the cab's coming. She said, oh, Mr. Corbyn, I'm sorry, we've got someone else. I said, who? She said, oh, I don't want to tell you. I said, you just tell me. I won't tell anyone. Okay. So she said, we've got the government's chief scientific advisor. I said, he knows FA. And I used the Queen's English version of FA. And that somewhat terminated the conversation. But, what did he say? He doesn't know. He had nothing to say except promoting the CO2 story, which is an abomination. It is a shame. 2013, we predicted a very late spring. So I entered the British asparagus start of season forecast competition, where you've got to predict when field grown asparagus is ready for market. And I said it's going to be 5 minutes late. It's normally meant to be St. George's Day it's ready, but it was going to be 5 minutes late. So, that's, 5 months, sorry, what did I say? 5 weeks late. So I said that British field grown asparagus will be ready for market 5 weeks late. Okay? And that was about right. That's what happened. So I won. I won those boxes of asparagus, as you can see on the picture, which was very nice. It was very nice asparagus. Of course, you might say, well, so what? But of course, it's very important for farmers. This means it was a late spring, a very late spring, and those farmers who bought our forecast took good advantage of this. Here's another quite an important thing we predicted. A big hurricane tropical storm. We predicted an R5 period. This is extra inputs from the sun. And you see in the top left graph, it meant the solar wind temperature and solar wind speed went up in the period of the R5, which was the 1st to 4th of December. And the geomagnetic activity went up. If you look at that graph, it goes up between the 1st and the 4th. The red bars show it's quite important amounts of geomagnetic activity. And the interesting things are there was a hurricane formed there, Hurricane Hermine, which went through Florida. And the most rapid development time of that hurricane was shown on the graph with the purple arrow, which is in the middle of the peak of geomagnetic activity. And when that peak ended, we had the red arrow, after which the central pressure of that hurricane started increasing again. And after it had gone through Florida, this hurricane had shifted to the right from the official track, which is really interesting. But that completely supports our predictions of that, namely in those circumstances, certainly tropical storms or big storm systems will shift to the right in the northern hemisphere compared with standard meteorology forecasts. Our storm forecasts over the last many years have been highly skilled, and there's just some of them there. One of them we announced at the Grain and Food Trades Association in 2013 in Geneva, 5 months ahead, and it came on time. Called Storm Jude, it was, by the Met Office. They suddenly started naming things to make them sound more dangerous. But, we predicted it. It should have been called Storm Weather Action, maybe. Anyhow, there we are. Now, interesting question here. Sometimes we've had these R5 periods when the storms have happened when we said, and even earthquakes and stuff. But there's been very little evidence of much in the solar wind or geomagnetic activity. So we're predicting something which comes, but there's like a missing link. So that means there must be something else going on. Now, I mentioned electrical connections. What we think is there are these things called Birkeland currents, which are double currents in and out, but they connect probably, this is electric universe theory or ideas, it's what the heading is. They connect the sun and the planets, and they probably connect stars to each other, and so forth. There's a lot of things going on which we can't see. So what we think was, in that particular period, Birkeland currents were going on. It will soon be possible to measure and observe Birkeland currents, courtesy of the American taxpayer, which is very nice. All right, well, what about what standard meteorology has achieved in these similar times? Well, the scare stories of the IPCC and the European Union, who are right hand in glove with them in promoting the CO2 story, have comprehensively failed. Okay, the upper pink graph here is the IPCC temperature scenarios, and the blue is their CO2 scenarios. The CO2 was about right. It certainly went up when they said, perhaps not as much, but it went up. Their temperature scenarios, though, on the data they started with, they said it'd go up. The temperatures went down. And this was from up until 2008 or so. Well, so what did they do? That should have been the end of the story. They should say, okay, we were wrong, we don't know what we're doing, our model is incorrect. But no, this is what they did. They changed the facts. They changed the facts. I repeat, they adjust temperatures. I mean, the Climate Research Unit of East Anglia was caught changing temperatures, if you remember, to hide the decline of temperatures after the medieval warm period, for example. But data now is being reprocessed on an industrial scale to give a different picture from what the true data represents. So the real data is around. There's a typical one, the measured data, the raw one and the blue one, and there's the pink one or the orange one, which was their reported averages. So you have to go back to original data or make sure you've got it before it's changed if you're going to make use of it, which is a sad situation. You can go to Tony _Heller, for example, on Twitter to find out more about this, but there are many links about it. Now, you can see this graph here where basically, and they admit this, is there are different data sets put forward from the Climate Research Unit of East Anglia, and they change them so that after a few years the effect of them has been to increase temperatures compared with the past by at least half a degree. That was as in the data there, up to about 2010 that goes. But the situation's got worse now, so the adjustments and trickery are worse than that. And I say it is trickery. I mean, it's amazing to think this happens. But the reality is that we have declining temperatures as shown in that graph there at the bottom using satellite measurements. So there'll be fluctuations all the time, but basically it's downhill now. Quick summary here of what they told us was going to happen in 2000, what they said was going to happen in the next 10 years. World runaway warming? No, the world's got colder under real data, even though CO2's gone up. Droughts and heat waves in the UK? No, we've had floods cold and hell. The end of snow? My God, we haven't had the end of snow at all. We've had dramatically more snow. More USA hurricanes? No, there's been less. And American hurricanes are the most, counted hurricanes in the world. They know what's happened. I mean, there's more measurements to make, and the effect of that is they more often find extreme high winds, but, counting them, is pretty clear. And we were told we'll have early springs. No, we've had late springs. We're told we'd have large sea level rise. No, the rate of sea level rise has not changed hardly at all for hundreds of years, so far as we can measure. But certainly in terms of the before and after the Industrial Revolution, the rate of sea level rise has not changed. So this extra CO2 produced there allegedly by man, but probably just after effects of the medieval warm period, has had no effect. And now we have, oh yes, if it's suddenly a cold blast, they say it's caused by warming. Look, this is against the second law of thermodynamics. You know, if they come up with that, they've got to show a detailed mechanism of how the second law of thermodynamics is being broken. And they can't. If they want to break the second law of thermodynamics, okay, but you know, it's a no-no. Right, so important things to know about the developing little ice age, and you can read through this on the slides available on the PowerPoint. But we did warn there would be more possible sandy type storms because of bigger contrasts happening between hot and cold due to wild jet stream. That sandy type storm was the one which went north on the coast of the USA and then suddenly hit west. You get more and more rapid changes of weather. You get more giant hail, as in 0.6 on there, and tornadic developments in certain circumstances. That has happened. There's been an increase in major earthquakes and volcanism. Our warnings of what would happen now were made over 10 years ago, and they are coming true. So I'll end part 3 there, and hope you're going to come back to look at part 4, which is about the politics of it all. Thank you.